Hello guys, this is Justin Bibilan and welcome to this episode of Don't Panic, It's Organic.
Ilalaban kahit kanino, oo, simple lang ako at malabo mong magtipuhan. Kaya okay nang kahit sa FB mo lang mapusuan. Kasi di na mapigilan ng sariling mapaibig sa iyo. Ano ba to? Gusto ka laging
So for example, how do we name this alkene? So rule number one, you should find the longest continuous carbon chain. So where is the longest continuous carbon chain? You have 1, 2, 3, 4, 5, 6, 7. You have 1, 2, 3, 4, 5, 6, 7, 8. Okay, you have 8. You have also 1, 2, 3, 4, 5, 6, 7, 8. So this is also 8. So you have also 1, 2, 3, 4, 5, 6, 7, 8. Also, it's not continuous, this one. 1, 2, 3, 4, 5, 6, 7, 8. That would not be your numbering because you need to pass the carbon to carbon double bond. So if you're going to number this as 1, 2, 3, 4, 5, 6, 7, 8, you are not passing the carbon to carbon double bond. So you need to pass that. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. That would be your uh, first numbering. Okay, or this one. So in this case, you already passed the carbon to carbon double bond. Okay. However, the rule number two would states that rule number one should be a longest. Okay. So what would be the longest continuous carbon chain? So this would be the longest continuous 1, 2, 3, 4, 5, 6, 7, and 8. Because if this one, that would only contain 7 carbon. However, on that side, that becomes 8 carbon. Okay. And rule number two is you number your longest continuous carbon chain in such a way that your carbon to carbon double bond would have the lowest number, would attain the lowest number. Okay, so if you're going to number this as 1, 2, 3, 4, 5, then therefore your carbon to carbon double bond would have on carbon number 5. However, if you're going to number this as 1, 2, 3, 4, 5, 6, 7, 8, so your carbon to carbon double bond would attain the lowest number, which is on carbon number 3. Okay, so you should number this as 1, 2, 3, and that would be 4. Okay, and this would be 5, and that would be 6, and 7, and you have carbon number 8. Okay, so that is how you number them. Okay, what are the substituent? You have methyl, that is an alkyl, at 3 carbon alkyl. That is actually, so if it is an alkyl with 3 carbon, so if it is an alkane, that is actually propane. But if it lacks 1 hydrogen, that is actually an alkyl, which is what do you call that? Alkyl. That is actually a propyl. So this is actually a propyl substituent. Okay, that is propyl. So I already discussed to you about alkyl groups. So you need only to review how do you name alkyl groups. Okay, so that is a propyl. So this is methyl. Okay, so which comes first, methyl or propyl? Methyl. Okay, because remember, it should be alphabetical. Okay, so M will be the first one, then followed by your P. Okay, so this is P. So M would be the first one. Okay, you have 3 methyl, 4 propyl, then 3 octene. Okay, so that becomes 3 methyl. Okay, that becomes 3 methyl, 3 methyl, then you have 4 propyl. So remember how do you gonna write that? The dash and the number. Okay. Then your parent, which is actually 3. So your carbon to carbon double bond is on carbon number 3. Then that becomes, so it is actually 8 continuous or longest continuous carbon chain. Then that, if it is an alkane, then that is octane. However, this is an alkene, so therefore this is octene. Okay, so 3 octene. So 3 octene. So there's an E there. Okay. So that is now the name of this compound. That is 3-methyl 4-propyl 3-octane. Okay, let's find out. Okay, that is the answer. 3-methyl 4-propyl 3-octane. Okay, very good. Okay, next. How about this example? So you notice that it contains a carbon to carbon triple bond, and you would expect that this compound is actually an alkene, an alkane, or an alkyne. An alkyne. Okay, so this is an alkyne because it contains a carbon to carbon triple bond. So remember, you number your longest continuous carbon chain. So 1, 2, 3, 4, 5, 6. I think that would be the longest continuous. So 1, 2, 3, 4, 5, 6 also. The other one is 6. But remember that if you're going to number your longest continuous, first priority should be your carbon to carbon triple bond would attain the lowest number, and also your substituent would have the lowest continuous carbon lowest number. Okay, so if you're going to do this as 1, 2, 3, your carbon to carbon triple bond would contain the lowest number. However, your like 3, 4, and 5, your substituent would have to attain a higher number. That becomes 3, 4, 5. So that becomes 5, 5. Okay, however, if you're going to number this as 1, then this would be 2, and that carbon here would 3, and this would be 4. Then you have 5, and that becomes 6. So in that numbering system, both your substituent and your carbon to carbon triple bond would actually attain a lowest number, okay, for that numbering system. So that is how you number that. Okay, your continuous carbon chain, your longest continuous carbon chain. So that is 1, 2, 3, 4, 5, 6. So your carbon number 3 contains the carbon to carbon triple bond, and your carbon number 2 contains two substituent, which is actually a methyl, both methyl substituent. Okay, what would be the name of this compound? Okay, you have two. On carbon number 2, you have two methyl attached. So if it has the same substituent on that carbon, so that becomes 2, 2, because it's the same substituent. So that becomes 2, 2, and you actually write first the prefix, that what prefix that is actually for two same group, that is di, and what is this group here? Alkyl, which is actually a methyl. Okay, so that becomes 2,2 dimethyl. Okay, 2,2 dimethyl. Then your parent compound, that is actually on carbon number 3, which is an alkyne. What alkyne? So it is a 6 carbon. So that is actually a hexane. Okay, so 3 hexane. So this is now the name of this compound. This 2,2-dimethyl 3-hexane. Okay, the answer, 2,2-dimethyl 3-hexane. Very good. So we have our next example. So what would be the name of this compound? So this is actually a cycloalkene because it is a cyclic hydrocarbon, which actually contains a carbon-to-carbon double bond. So remember that if you are going to name this compound, so remember the rule number 1. So you should attain the longest continuous carbon chain. So it is a cyclic. Then you would expect that it is cyclo, which which actually contains a carbon, 6 carbon. Okay, you have 1, 2, 3, 4, 5, 6. Okay, so if it is an alkane, then you would expect that it's actually a cyclohexane. But however, it contains a carbon-to-carbon double bond, then you would expect that it is a cyclohexene. So the parent compound should be cyclohexene. It contains only a one carbon-to-carbon double bond. However, how do we number this? So how do we number this? So if you are going to number this as 1, 2, 3, just to attain the lowest number for substituent, that is actually very wrong. Because if you're going to number this as 1, you need to pass the double bond. So that means that would be your carbon number 2, not that here. So this is not a carbon number 2. Okay, so if you're going to do that, this is your carbon number 1, then that becomes your carbon number 2. And this would be carbon number 3, 4, and this would be carbon number 4, and that would be carbon number 5. So in doing that, your substituent is actually on carbon number 5. So that is not the lowest number. So if you're going to number this as, this would be your carbon number 1, and that would be your carbon number 2, then therefore this would be your carbon number 3, and that would be your carbon number 4, then you would attain the lowest number for the substituent. So that becomes 4-chloro. Okay, 4-chloro. Then you cannot include the number for the cyclohexene, like 1 cyclohexene, because it's actually understandable that it should be on number 1 because there are no other carbon to carbon double bonds here. So it has only one carbon to carbon double bonds. Okay, so you would expect that this is actually a cyclohexene. So you will not anymore put the number 1. Okay, so the answer would now be 4-chlorocyclohexene. Okay, so that would be the name for this compound. So the name would now be 4-chlorocyclohexene. 4-chlorocyclohexene. Okay, very good. Okay, next. So what would be the name of this cyclic compound? Okay, so you would expect this is a cyclodiene. It's because it is a cyclic which actually contains two carbon-to-carbon double bonds. So what cyclodiene is this? It actually contains how many carbon? You have 1, 2, 3, 4, and 5. So you'd expect that the parent would be a cyclo, oh, what's happening to my pen? Pentadiene. Okay. From the root word penta, which means 5 carbon. So that is penta. And you have your diene because it is actually 2 carbon to carbon double bond. Okay, that would be your parent compound. Okay, so how do you number your cyclic diene? Okay, this is your carbon number 1, then that would be carbon number 2. So to attain the lowest number, that should be 1, 2, 3. What happened? 3 and 4, and this would be 5. Okay? So that your substituent, which is actually a methyl, so that is a methyl, would attain also the lowest number for carbon. So you have 3-methyl. So that, what's happening? That becomes 3-methyl. 3-methyl. And your double bonds are actually at carbon number 1, 2, 3, and carbon number 4. So that becomes 1, 4. Okay? So 1, 4 cyclopentadiene. So the name would now be 3-methyl 1,4-cyclopentadiene. So 3-methyl 1,4-cyclopentadiene. So you have your problem. Draw a complete structural formula for each of the following compounds. We have 1-bromo 3-hexyne. So how are we gonna draw the complete structural formula for 1-bromo 3-hexyne? So lately we name compounds. So given the compounds, then we name it according to the IUPAC system of nomenclature. So for this case, for this problem, so given the name, then how are we gonna draw the structural formula? So you have 1-bromo 3-hexyne. So first is we're going to determine the parent compound. So the parent compound is actually hexyne. So that means it's a 6 carbon, which is an alkyne, okay, because it actually ends with YNE. So you would expect that this 6 carbon contains a carbon to carbon triple bond. So you have 1, 2, 3, 4, 5, and 6. But where is the carbon to carbon triple bond located? It's actually in carbon number 3. So 1, 2, 3. So this is where the carbon to carbon triple bond is located. Okay. Then you have also a substituent, which is actually a Br. That is actually a 1-bromo. Okay. So you have 1-bromo. Then don't forget that your carbon should have a total of 4 bonds. Okay. So that carbon there and this one would have 3 bonds. So notice that this is actually completed 3 and 1, then also 3 and 1. So then those bonds are actually come from the hydrogen. Okay, that is where your hydrogen is. Those bonds there. This one also, and that one, and this for your hydrogen. This one also. Then you're done. This is now the structural formula for 1-bromo 3-hexyne. Okay. Next, you have 3-iodo 1-nonine. Okay, so this is also an alkyne, which actually contains a 9 carbon because it's non. So that is 9. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 7, 8, 9. Okay, so your carbon to carbon triple bond is located on carbon number 1. And your substituent, which is actually an iodine because it is iodo, it's actually in carbon number 3. So you would expect that your carbon number 3 would contain an iodine. Okay, then don't forget that your carbon contains 4 bonds. So you have bond there. So this also has lacking 2 bonds. That would be lacking 2 bonds. This one also lacks 2 bonds. One, this one, and the last lack 3 bonds. And those bonds will be coming from your hydrogen. So you're going to write all the hydrogens there. Okay? So that's it. It's only very easy and very basic. Okay? And the last one would be 2,4-hexadiene. Okay, so in this case, this is a alkadiene. Okay, correct, because it is actually hexadiene. Since it's hexa, then you'd expect that it actually contains 6 carbons. Okay, 1, 2, 3, 4, 5, 6, and it is a diene. Then that means it contains 2 double bond because it's a diene. 2 double bonds. So, but where does the 2 double bonds located? On carbon number 2 and carbon number 4. So 1, 2. So you have a double bond there. So 1, 2, 3, and 4. And also on carbon number 4. Then you just have to complete the 4 bonds. Then it lacks 1. Also lacks 1 carbon there. Lacks 1 carbon. Lacks 1, no, not carbon, hydrogen, I mean. Lacks hydrogen. Okay? Then you just have to write all the hydrogens that are lacking on your structure. So those are all 4 hydrogens there. Also hydrogens. Then you can also write the condensed structural formula if you want. So, but the question says it's structural formula. Okay, so it's very easy and very basic.